Hello again, tribe. Welcome into the second part of the three-part series for the final exam preparation course for the algebra, equations, and inequalities. Now, in this video, we'll be looking at different types of the questions that you'll be typically getting for you on your final exam. So, if you haven't done so, please be sure that you subscribe so that you won't miss when the third part series gets uploaded. So, without further ado, we're gonna go straight into this part. Now, in the first question, as you can see, we have 1.1, 1.2, 1.3. We have still different type of questions on 1.1 and on 1.2 and 1.3. So let's go ahead and start with the 1.1. So, in the 1.1 questions, we want to solve for x. So let's go ahead and start with the first one, 1.1.1. So here we are given 3x squared plus 5x equals to 7. Now here, as you can see here, they said we need to correct this to two decimal places. So it means now the first thing that we need to do is we need to first have a standard form, right? And then now, since here they said we need to correct this to two decimal places, it means we're going to use the quadratic formula. So let's go ahead first and write this into the standard form. Now there's going to be 3x squared plus 5x minus the 7 equals to 0. So this gives us a as 3, b as 5, and c as minus 7. Now let's apply the quadratic formula. So applying the quadratic formula, we get b squared minus 4ac all divided by 2a. And then now when you substitute here, we're going to have 5 plus minus 5 squared minus 4 into 3 minus 7, all of that divided by, sorry about this one, all of that is going to be divided by 2 into 3. Now let's go ahead and press this on our calculator to see what you're going to get here. So when you press on our calculator, you're going to see that x equals minus 2,57, or x equals 0,91, and that is the solution for 1.1.1. Now let's go ahead and jump into the second one. So 1.1.2, then here we're given 2x squared equals to 9x plus 5. Now here the first thing that you need to do is what? Standard form. So let's go ahead and do that. 2x squared minus 9x minus 5 gives us 0, right? Now it's standard form. That means now we need to factorize. If you don't know how to factorize, please make sure that you go to the preparatory video that I've made for you. In that video, I explained to you easily on how you can factorize on any quadratic equations. So now let's go ahead and factorize this one. I see we're going to get 2x and 5, and then we're going to have 1 and x, then it's going to be minus and a plus. Now simplifying this, you're going to have x is minus 1 over 2, or x is equals to 5. So I hope that makes sense. And then now let's go ahead and go to the next question. Now in the next question, it's going to be 1.1.3. Right, so let's go there. We have x squared minus 5x is greater than minus 4. X squared minus 5x is greater than minus 4, right? So what's the first thing we need to do? Again, standard form, right? X squared minus 5x plus 4 greater than 0. And now we're going to factorize here, right? 0, so we're going to have x, 1, and 4 minus minus. Now this gives us critical values as x equals 1 and x equal 4. Now let's go ahead and draw on our sketch. So we're going to have 1 and 4, and then we're going to have our sketch over there. Then now here we're going to discuss what does greater than 0 mean. Now greater than 0 means that these are the x-axis, and so we're going to look over above the x-axis, right? So these are the x-axis. Now here we can see these x's, let's call them x, right? This shaded area, let's call it x. Then we can see this shaded area is on the left of 1, right? So it's on the left, it's pointing on the left of 1. And then this shaded 1, if you call it x, we can see it's on the right of 4. and that gives us the final answer for 1.1.3. Now let's go ahead and look at 1.1.4, right? Now let's go back there. 1.1.4, we can see we have x minus 3x to the power of 1 over 2 equals to 4. So it's x minus 3x to the power of 1 over 2 equals to 4. All right. Now here, the first thing that you need to ask yourself here is this: is this equation a quadratic equation? Because remember, I said that on the first type of questions, 1.1, we always need to have a standard form. Now, is this equation quadratic? The answer is no. Why is it not quadratic? Because here, this x here is a power of 1, and this one is a power of half. So for this to be quadratic, it was supposed to have a power of 2, this first one, and the second one to have a power of 1. Now, is there a way we can do this? Yes, there's a way. So how we can do this? We can do this by doing the K method, right? So K method, we're going to apply it this way. So here, we're going to let K to be the expression or the variable that has a power of half, and then we're going to make K squared to be a variable we have that has a power of 1, right? Now, this then automatically gives us K squared, right, minus 3k equals to 4. Now, as you can see here, this thing is similar to this one, but now here it is squared, but here it wasn't squared. So this then means this is a quadratic, and so we can write what is standard form. So let's go ahead and do that. K squared minus 3k minus 4 equals to 0. Now, factorizing this, you can see we have k and k, 1 and 4 minus and plus. This gives us k as minus 1, or k is equals to 4, right? So now here, what do we do after we've solved for the value for k? We're going to take back the value that we had for k. So we knew that k is x to the power 1 over 2 equals to minus 1. Then on the other side, x to the power 1 over 2 is equals to 4. Now, the reason why we're taking it back is because we're trying to solve for x, remember, not for k. So what we're going to do here, we want to square both sides, right? So when you square here, this cancels with this, and then x here becomes 1, or in this case, when we square both sides, right, here we get x is equals to 16. Now, because of here, we have applied the K method. Instead of ending our solution here, what you need to do is we need to test if these solutions are true. Now, how do we do that? By testing, it means we need to take this x is equal to 1 and substitute it in these values for x here. Now, substituting this, if we get the value of 4, then it means our statement is going to be true, right? Which means this x is going to be a solution, but if not, it means it won't be a solution. Now, if we do this on this first one here, on x is equal to 1, you will notice that here, whenever x is equal to 1, you get an answer of minus 2. So instead of getting a 4, you get minus 2, so it means this is not a solution. But now if you do the same thing on x is equal to 16, you're going to get exactly 4, so which means this one is a solution, and that then means this one is your final answer. Now, I hope that makes sense. Now, let's go ahead and go into the second question. Now, in the second question, they say we need to show that 2 to the power of 2x plus 1 plus 7 times 2 to the power of x minus 4 equals to 0 has only one solution. So now here, we just need to solve for x here. Now, let's go ahead first and write this thing down. So we have 2 to the power of 2x plus 1 plus 7 times 2 to the power of x minus 4 equals to 0. Now, how can we show if this has only one solution? So we can show this by actually solving it and see if you're going to have one solution here. So how do we do this? First thing is, here we can see this is an exponential equation. It is not a quadratic what? It is not a quadratic equation. It is an exponential equation because here the variable x is in the exponent. So now let's decompose this one first. So by decomposing here, we're going to get 2 to the power of 2x times 2 plus 7 times 2 to the power of x minus 4 equals to 0. So now if you're trying to solve for this, we need to make sure that we write it in the standard form, right? So first thing that we're going to do is write it, put the 2 in front, all right? And then it's going to be 2 times 2 to the power of 2x plus 7 times 2 to the power of x minus 4 equals to 0. Now, here you might wonder if this is a quadratic or not. The answer is no, it's still not. Why? Because we still have exponents, right? So this then means now to make this a quadratic, what we're going to do, just like we did earlier, K method, right? So now, what are we going to do here? So in this K method, we're going to make K to be 2 to the power of x, right? Then K squared is going to be 2 to the power of 2x, right? All right. Now, if we do that, we're going to have 2k squared plus 7k minus 4 equals to 0. Now, this is a standard form, and because of it's a standard form, it means what? It means we can factorize it. So let's go ahead and do that. So we're going to have here equals to 0. So there's going to be 2k and k, and then we're going to have 4 and 1, and then we're going to have a plus and a minus, right? So this then gives us final answer of k is half, or k is minus 4. Now let's go ahead and change these values. Now since we have solved for k, we're going to take k to be 2 to the power of x is equals to a half, and then here we're going to do the same thing, 2 to the power of x is equals to minus 4. Now if you see over here, 2 to the power of x is an exponent, and then here we see we have an answer that is negative. So here this means that this is not a solution. Why? Because we have an answer that is negative here. Now let's go ahead and look over this one. Now we have 2 to the power of x equals, now what we're going to do is, because of we're dealing with exponents, we know that every time you're solving for an exponent, you need to make sure that the bases are the same so you can equate the what? The powers. Now here 1 over 2, we can write this as 2 to the power of negative 1. The reason why is we're trying to make the bases the same so we can make x to be equal, both x's to be equal. Then as you can see here, our answer is just one solution, and hence then our solution is done. Now let's go ahead and look over third question. Now third question, simultaneous equation. So you want us to solve simultaneously. So what we're going to do is we're going to let x to be y minus 13, equation 1, square root of 2 minus x to be equals to y minus 3, and then equation 2, right? Now here we need to take one easy equation and make it equation 3. As you can see here, equation 1 is already solved, so I can just write it again here and do nothing on it, and then just call it equation 3, so that we don't change the method that we've been using here. Now let's substitute 3 into what? Into 2. Now 2 is 2 minus x equals to y minus 3. Now let's substitute. So we're going to have 2 minus y minus 13 equals to y minus 3. This then means now here we have a square root of 2 minus y plus 13 equals to y minus 3, right? Now here becomes square root of minus y plus 15 is equals to y minus 3. So what we're going to do here, just like we did, we're going to square both sides, right? So now squaring both sides, it cancels the square root this side, and then we left with minus y plus 15. But on the other side, this is an expanded what? Product. So we're going to expand it and write it as a product. So writing it as a product, I'm going to multiply each and everything out, right? Now minus y plus 15 is equals to y squared minus 3y minus 3y plus 9. And then now what do we need here? We need to have a standard form. Now what we're going to do is I'm going to take these ones over, and I'm going to leave 0 here, and then it's going to be y squared. Now minus 3 minus 3 is minus 6y. Then taking this minus y across is going to give me plus 1y. Then here we have 9 minus a 15. Now 0 equals to y squared minus 5y minus 6. Now I can rewrite this and say y squared minus 5y minus 6 equals to 0. Now standard form, let's go ahead and factorize. Now by factorizing, I have y and y. Now the factors here is going to be 6 and 1 minus plus. Now y is going to be 6, or y is going to be minus 1. Now what are we going to do? We're going to substitute the values on equation x is equals to y minus 13. Now when you substitute here, when y is equals to 6, we see that x becomes 6 minus 13. Now x, what is 6 minus 13? 6 minus 13 gives us minus 7. Now let's look at over this second one. Now the second one is going to be x equals to minus 1 minus 13. Now x is going to be minus 14. And that is all for the second part of this series. Please be sure that you haven't forget to subscribe, and I'm going to see you on the next part series.